Before we begin Unit 20, here is the answer to the Unit 19 question. The best answer is choice B.
The consensus in the legitimate scientific community is that in order to attain a sustainable society, we must undergo a responsible and efficient shift to non-renewable energy within the next half-century. During the transition period, non-renewable energy resources must be used efficiently and responsibly, as they provide the greatest net energy of all currently available energy options. Although nuclear energy provides a reliable source of high-quality energy, it has a low net energy output, while facility design, human error, materials handling, and proper disposal of associated hazardous waste will continue to pose environmental concerns well into the future. Unit 20. Doable Renewable Energy.
Discussing renewable energy is uplifting because it brings with it the hope of a truly sustainable future.
In order to continue our way of life, we must transition to renewable energy, and in the process, use our non-renewable resources effectively, efficiently, and sparingly.
In this unit, you will be introduced to technologies that rely on current as opposed to ancient sunlight.
Keep in mind that this conversion process will not happen overnight, and we must first learn to manage our non-renewable resources wisely in order to allow sufficient time for a successful transition to occur.
The science of perfecting energy efficiency is called energy conservation. Every second, incredible amounts of money are lost in the United States and in many other countries around the world due to energy waste.
There are specialized firms dedicated to helping companies and individuals improve the amount of work they get out of every unit of energy consumed. These firms get paid when their clients save money on energy costs.
The important thing to remember is that when energy is recovered, we not only save money, but we also prolong our fossil fuel reserves, lessen our dependence on foreign countries, reduce pollution, and buy time to transition to renewable resources.
You can start helping right now by picking up your smartphone and searching personal methods of energy conservation to find a myriad of simple things everyday people can do to save energy and money.
Millions of people practicing even the smallest of these individual energy conservation strategies will lead to a significant economic and environmental gain.
Renewable energy flows from the sun through the environment and into space as heat. This is analogous to electricity flowing out of the socket, through the television, then into the room as heat.
Notice that in both examples, unused energy was lost to the environment as wasted heat. What if we could improve the efficiency of this process and put the unused energy to work for us?
The basic concept behind sustainable design and green architecture is to use our technology to utilize more sunlight and reduce the radiant heat loss.
Innovative people are hard at work designing cars, buildings, and cities that are no longer dependent on fossil fuels and run or operate completely on current sunlight by using more of the available energy.
During the transition to these futuristic designs, existing structures are currently being altered to integrate sustainable concepts.
There are too many new and exciting renewable energy strategies to present in this program. However, let's take a look at a few examples of these kinds of technologies.
Cars are being developed that are capable of operating on fuel cells that are twice as efficient as the internal combustion engine, require minimal maintenance, and run on hydrogen gas.
If the hydrogen gas is produced using solar power, carbon dioxide and other air pollutants will virtually be eliminated.
Buildings are being constructed that take advantage of as much solar energy as possible, employing passive solar heating systems, solar cells to generate electricity, and solar hot water heaters.
These buildings often recycle their own wastewater, use only high-efficiency appliances and lighting, and have green roofs and other areas where people grow their own food.
An organization known as the World Green Building Council established what is called the Leadership in Energy and Environmental Design, or LEED program, that issues building ratings and certificates based on how well buildings meet standards in energy efficiency.
These new eco-friendly buildings may potentially save billions in future electricity costs.
So, how can energy from the sun be transformed directly into electricity?
Very simply described, a turbine is a machine that spins magnets around a wire to produce electricity. Solar thermal systems collect and concentrate solar energy in order to boil water. The resultant steam is used to turn turbines.
Using solar energy to produce electricity on a large scale has minimal environmental impact and emits virtually no air pollutants.
However, it has a relatively low net energy output and without government subsidies cannot compete economically with fossil fuels at this time.
The process also requires large amounts of water, rendering it impractical in some situations.
Another method of transforming sunlight into electricity is the photovoltaic or solar cell.
Solar cells are made from sheets of silicon and small amounts of certain metals that allow them to produce and conduct electricity.
When the sun shines on the cell, it emits electrons that are able to move through the metals, producing an electrical current.
Solar cells provide a moderate energy yield, produce no air pollution, can be moved from place to place, and are easy to install.
In order to be effective, however, solar cells need energy storage systems and constant access to the sun.
Large solar plants require significant land allocations that can be detrimental to ecosystems.
Indirect energy from the sun can also be transformed into electricity.
Precipitation or rain is part of the water cycle driven by the sun's energy.
Flowing or falling water is an example of kinetic energy. As water flows across the land, there are ways to put this energy of motion to use.
Hydropower is the term used for harnessing this energy and turning it into electricity.
By building dams, water is raised and acquires potential or stored energy since it now has the ability to fall.
When water falls, the potential energy is released and used to power turbines that generate electricity.
Hydropower has the potential to deliver a high net energy yield and produces low-cost electricity with virtually no air pollution.
The problems with hydropower are that large areas of upstream land must be reallocated and downstream ecosystems may be permanently impacted.
Wind is another indirect way to use current sunlight.
The uneven heating of the Earth's surface by the sun causes wind.
It's becoming common to see a single electricity-producing wind turbine or tens to hundreds of these machines interconnected, creating what are referred to as wind farms.
Depending on their location, wind farms can deliver moderate to high energy yields and produce low-cost electricity to consumers with little to no air emissions.
The disadvantage of using wind turbines are that they are not always reliable, so backup systems are needed. Low-level noise is produced, and some people believe they contribute to visual pollution.
Since plants use the sun to grow and store energy in their structures, it's reasonable to think we can use them as a source of renewable energy.
We can extract energy from biomass by either burning the plants directly or transforming their structures into biofuels.
Burning biomass works if the plants are harvested and replanted sustainably. However, this is rarely the case.
This practice has a high environmental impact and results in soil erosion, water pollution, and habitat loss. Carbon dioxide emissions are also a concern with unsustainable burning.
Converting biomass into biofuels reduces carbon dioxide emissions and delivers a high net energy yield for certain crops, such as those producing palm oil.
Unfortunately, we are already in a food crisis, so growing crops for energy competes with agriculture. In addition, replacing existing ecosystems with cropland negatively impacts the Earth's biodiversity.
A fuel cell generates electricity directly from a chemical reaction. A hydrogen fuel cell combines hydrogen and oxygen to produce electricity, heat, and water.
This process is the reverse of electrolysis, in which electricity is run through water to produce hydrogen and oxygen gas.
If a solar cell is used as the electricity source for the electrolysis, theoretically, the fuel cell can produce perpetual energy.
This may sound too good to be true, and at least for now, it is. Until improvements in the technology can be made, fuel cells have a negative energy yield, and the high costs of applying this process require subsidies in order to put it to practical use.
Again, these are just a few examples of renewable energy technologies that will soon be capable of freeing us from our unsustainable reliance on fossil fuels.
Presently, none of our renewable energy options can compete economically with fossil fuels, but we have no choice but to make the transition to them, and that's where teachers come in.
We're in a race against time to transition to renewable energy before our fossil fuel reserves run out.
In addition, the quicker and smoother the transition, the less environmental degradation will occur.
If environmental education is successfully infused across the country in our K-12 curriculum, our children will be better suited to contribute to the development of clean energy alternatives and effective methods of extending existing non-renewable energy reserves.
At the very least, our graduates will become eco-literate as well as career and college ready. Here's your question for Unit 20.
Which of the following is not an example of green technology?
Choice A. Cars capable of operating on fuel cells that are twice as efficient as the internal combustion engine, require minimal maintenance, and run on hydrogen gas.
Choice B. Buildings that take advantage of as much solar energy as possible, employing passive solar heating systems, solar cells to generate electricity, and solar hot water heaters.
Choice C. Nuclear power plants capable of producing a high net energy yield.
Or Choice D. Hydropower plants capable of harnessing the energy of flowing water.
The answer and explanation are provided at the beginning of Unit 21.